Hi everyone. Good morning, good evening. So let's get started. Let me quickly share my screen. All right, let me know once you're able to see the screen so that we can get started with what we have to cover.
Yes, we can see.
All right, thanks for confirming. Okay, so one second. What is this? Okay, all right. Yeah, so in the previous lecture today, we saw the deployment of the Azure components, right? We were able to deploy the containers for Azure resources. Then we tried deploying the AKS cluster, and we were able to set up the Azure Container Registry uh, for storing the backend state file for the Terraform. And then we also deployed some other resources as part of our Terraform deployment. Now, one thing which we still need to cover is like what exactly is this specific project about? So I'm pretty much sure that you all might have gone through this particular file which we have, right? So ideally, if you'll take a closer look at it, these are most of the things that we are covering as part of this session. But even to give you a better understanding of how exactly we came to this particular project structure, let me quickly spend 1 or 2 minutes to, set an understanding of where exactly we are standing at the moment and how exactly we are traversing through these particular files. Okay. So you can consider this SRE tech here as our root project folder. And then within this particular folder, we have the deployments folder. Then we have something known as, so think it from various layers within our architecture. Now, this is something which I think I already showed to you previously. So you might be seeing multiple layers over here from the infrastructure perspective, from the application perspective, here, this one, from the database perspective, from the monitoring perspective, from the security perspective, here, this one, and then from some of the other perspectives. For example, there would be some code or something like that, all those kind of stuff. But we'll not get much deeper into that because that's not the main idea or the theme about this particular capstone. Our main goal is, to understand and focus more on how exactly we can achieve the best out of it from the SRE or the DevOps standpoint. Okay. So if you feel like I'm going much deeper into any of the developer concepts, uh, feel free to raise your hands and you can definitely ask me any questions because it's always good to have some understanding around those concepts. But yeah, if in case I'm going deeper into those, maybe you can just let me know and then we'll again come back to the line. Uh, so let's start with the infrastructure layer, which is the Terraform layer. Now, this is something which I think we already tried covering in our previous session. Uh, Here in this particular layer, we have basically this backend.tf file. This is something where we are, configuring the remote state storage in the Azure for maintaining or persisting the Terraform state. And then we have this providers.tf, main.tf, which is having the entire code for deploying the resources. Then we have outputs.tf, which is basically, to expose the output of uh, any particular file or any particular resource that we are deploying. So just following this format, it will be exposing or exporting that particular uh, name as the output. Then we have providers, which is nothing but the information about the cloud providers plugins. And then what is the authentication mechanism that we are planning to follow here uh, when we will be authenticating for the Terraform. And then we have this TF vars. Now, this is something which, here we are trying to assign some concrete values to the variables for our specific configuration. All the names, all the cluster names, DNS prefixes, node count, VM size, everything is something, everything here we are trying to define and configure. Okay. Uh, let's move to the application layer. I'll just give you a brief about it, and then maybe once we'll try to, deploy it, at that time also we'll have a look at how exactly those files are working here. So if you'll come to this Go folder here, right? Now within this particular Go folder, we have this Kubernetes artifacts. Now, what are these artifacts? So let's say you can consider this as the application layer. Now, if you'll come to, let's say, let's start with the secret YAML, right? Now, this is something which ideally would be used to store some sort of, let's say, some sensitive database credentials, uh, some secret or whatever, uh, you know, credentials kind of configuration things that you want to store. So all those things you will try to use some sort of secret Kubernetes secret as an artifact, and then maybe you could use secret db.yaml secret, whatever resource that you want to use that secret for, or whatever configuration that is bagged for that particular secret. You can append the name accordingly. But that is how the artifacts for the Kubernetes looks like. You will be having this file known as deploy.yaml. Now, this is something which you can consider as the uh, main logic deployment file, which is where we define how Kubernetes should deploy and manage the application pods, right? Uh, so just to give you a very brief walkthrough of this file here. So what exactly we are doing is like here it starts with the API version, and then the kind is deployment. Then we have something known as metadata, which is specific to your pod name, pod particular, I mean your name of the pod, or any specific labels that you want to attach to the pods, right? And then we have this deployment specification here, this particular block. So here you can configure how many number of pod replicas you want. Then this is the selector based on which, if in case you want to filter out any specific pod, you can use these kind of filters. Now, just to make you more comfortable around this, uh, this is something which you can always try to look at while you'll be, you can take some reference from this documentation. So this is the official documentation for Kubernetes. So let's say if you want to take idea of any specific file, let's talk about, uh,
Hey, Devansh. Devansh, able to hear me?
yeah, hi Dinesh.
Can you please remove the watermark? I am seeing the watermark on the screen. I think it is creating some confusion on the clean screen. Is
Oh,
it?
is it?
Yeah.
What kind of watermark is it?
Just an email is coming up. So others, please confirm. You guys are seeing watermark? Anyone? Aruna? So
No.
you're not seeing. That's okay then. All right. Yeah. Then I
Okay,
think you
all
can continue, Devansh. Maybe for me as an admin. That's fine. Yeah.
right. Okay, sure. All right. Thanks, Dinesh. Okay, so yeah, coming back to this documentation, right? Now this is something which you can always refer to, even for your understanding. And as I previously mentioned in our today's session, that if you ever plan to take any of these uh, certifications like certified Kubernetes administrator or application developer, they provide you this particular documentation during that exam, which means you can always refer to this for your better understanding of the syntax of those particular files. Now, even while trying to draft this particular project, I referred to the syntax for these particular files. This is the best go-to thing. Like now, this is one approach, and the other approach is you can use some kind of directive commands, which will try to create some boilerplates for any of the deployments or the resources that you want, right? So maybe I'll try to share the links along with the documentation that I'm following so that it would be easier for you to understand how exactly we are trying to create these artifacts. Okay. It's more like uh, you can consider it as a helping guide for you, which would be helpful, if in case you ever plan to understand how exactly these configurations fit in for this particular manifest file. Okay. Uh, then there are some other things here which we should be aware of. For example, I mean, these are just the specifications like node selector, image pull secrets. You can just specify the name of the secret. Then we have containers here. How many containers you want to specify? What's the specific name that you want to give to that container? What is the image that container should use while spinning up? What is the port that container should start on? If in case it's having some environment variables connected to it in terms of some URL, some secret it should use, right? Then should it use some port, some value? And then here it's more from uh, now this is something which should be concerning to you as an SRE engineer, which is you should be aware about how much is the RAM, how much is the CPU. Here we are using 256 MB RAM, which is basically the minimum. And then we are using 0.25 CPU cores, which is also you can understand as one of the minimum configurations. And then we have something known as the limits. Limits is something, where we are saying that it should have 512 MB of RAM as the maximum. And then CPU, we are saying it should have one CPU core maximum. So I guess you might be aware about the idea behind minimum and maximum. We are saying that at least it should have minimum this much memory, this much CPU, and then this is the limit that we are configuring that, okay, this is the maximum allowed limit for that, right? And then we have something known as the liveness probe. This is something which we'll again be looking into it later when we'll try to understand how the health check APIs are used. And then let's say if in case you want to understand and test if in case your system is up and running or this particular container is up and running, you'll just try to hit this slash health API and then you'll be able to understand uh, if in case your container is in a good state. Okay. Now, this file itself consists of the same code. I mean, it is up to you. Either you can create separate artifacts. For example, I could create another YAML here known as service YAML, and then I can paste this entire code in that file. Or else you can use one particular file known as deploy.yaml, and then you can try to include all the artifacts into one file itself. So it's completely an optional thing. Uh, this is specifically for the sake of convenience here, definitely why we are using it. But let's say if in case your organization is trying to be more structured around these artifacts, they might be using for different things. They could use container.yaml, a specific artifact for container itself, a specific artifact for service, for pod, or it depends solely on how exactly your organization wants that particular thing. Okay. Then we have this HPA YAML. Now, what is this? By HPA, I think we must be clear that, it is something which we are trying to configure some sort of horizontal uh, pod auto scaling, which means if in case there is a traffic spike, so in those cases, it should try to auto scale the pods. For example, if you'll see here in the specifications, uh, we are just specifying here scale target reference, which means which resource you want to scale. Now that resource is the deployment, which we just saw in the previous file. The name of that deployment would be Go app. And then we are saying that this is the minimum pod count which is the scale down limit. For example, if there is minimal or no traffic, you should sustain at least with one replica. And then if in case, there is a huge traffic spike, you should try to go up till maximum 5 pod counts. So that is what we specify with this max replicas as 5. And then we have metrics, which is, metrics based on which this scaling should be triggered. Now, again, these all configurations are something which you should be aware of. You should not be bothered about the syntax much because, again, you can refer to the same documentation. You will get this entire syntax over there. But yeah, now you should have a fair understanding of how much you want to use, because let's say if in case your your SOPs or your SLOs define that there should be some average value of the CPU. So based on that, you need to provide the value here. It should not be like, you're still using 250 uh, millicores. I mean, this M represents here millicores because this is something which we are targeting about the CPUs. Uh, so if in case your organization is saying that no, you should be using at least 1000 millicores CPU, then you need to give that particular value as the average value here. And similarly, we have for the resource, which is the memory. So this is what we are saying, that the average value at any given point of time, it should maintain this one. And if in case, it crosses the threshold, so based on that, the auto scaling should be triggered. Okay. Uh, and then we have something known as ingress. Now, this is something I think which we already walked through in our previous session. So this is basically acting as the load balancer layer for us, where we are trying to, understand how exactly or what all configurations would be needed for us in order to uh, enhance the security, enhance the redirections, enhance the routing of our particular application. Then this is something which we already covered. So coming to this one. Now here basically it's something that is telling us how exactly our operators should behave. Because as you can see, service monitor, what does this mean? This means our application is there, which would be having Prometheus as the operator. Now, Prometheus is something which we are using here as a custom resource operator to to scrape the application metrics. Uh, so whatever our pods, Kubernetes pods, uh, deployments would be consuming, that much memory, that much RAM, CPU, all of that metrics would be scraped from that deployment, and all of that thing would be visible to you using this particular operator. Now we'll come to this thing later, but this is just to give you an idea. So that later when we are trying to refer to these files, so that you have an understanding that, okay, what each file is supposed to be, taking care of. For example, here, if you'll see, we have this port HTTP, then this is the path that we are using /metrics. So this is the metrics endpoint path. And here, basically, it's the interval that we are saying that how frequently the scraping should be happening, how frequently this monitor or this Prometheus operator should be, you know, fetching the metrics of that particular pod. I mean, of the pods or of the CPUs and all that stuff. So this is the frequency which we define here, that every 15 seconds it should be happening. And then let's say due to any given situation, somehow the scraping is not being happening. So there should be a timeout. It should not be a synchronous loop wherein, your application uh, is having this operator which is kind of stuck while trying to scrape the metrics, even though the pods are down or something like that. So it will just wait for 10 seconds. After that, it will conclude that, okay, maybe that particular service is not healthy. Maybe that resource is not in a good shape, right? So this is about the Kubernetes application layer part. Okay. Now this is something which is usually taken care by all the organizations in the similar approach. They might be using some sort of Helm charts, Helm operators, all of that under the Kubernetes artifacts. Then let me walk you through the other layers as well. This is just for your reference, uh, so that you are able to get some good idea of how exactly we are designing our entire structure. So once we are deploying it, we'll be using these files which are there, all these artifacts. Okay. So here basically the purpose of this particular file, or the database layer, I should say, which is having this file, Postgres SQL YAML.yaml. So this is basically to deploy the Postgres as persistent storage. And this is something which we are trying to deploy using the Azure disk. Now, if in case you might be wondering why we have opted for any specific things, so this is something which we are trying to abide by the Capstone project. For example, any specific organization where you are going for some sort of uh, an assessment round, which means they would be giving you a take home assignment or something like that. Now, they would be specifying all these things very clearly over there that, okay, this is something that you need to use. Maybe they might ask you to use some sort of Cosmos DB, right? If in case they want to have some NoSQL follow-ups around. So all those kind of information would be mentioned in the documentation, and that is something which you should try to follow. Okay, so following the requirement that we have for this capstone project, we are trying to use this particular Postgres SQL DB over here. Okay, and then we also have the PVCs here. So PVCs ensure that the data persists across the pod restarts. For example, your pod just restarted. Now, usually you might have heard that Kubernetes is a self-healing orchestrator. Why do we call it as self-healing? Because even though if a pod crashes, it will again try to restart. But then there should be something which is still holding the volume somewhere, still holding the storage somewhere, right? So that binding is something which is taken care by the PVCs and the PVs. So this is the core which makes the Kubernetes pods uh, as self-healing. So this is the core behind that, right? Now, here in this case, since this is Azure managed Kubernetes, so Azure disks would be there, which will try to back these volumes. Okay. This is something which we'll try to refer when we'll be deploying this particular database as part of our database deployment. Now, next we have the yeah, I think this is something which we can cover. So this is about the monitoring layer part. Yeah, is anyone speaking something?
Sorry, I joined little late. Did I miss anything?
No, we are just trying to cover the directory structure as of now and how exactly, the files would be used throughout this uh, capstone project. So we are just trying to understand how these files are playing some important role in terms of this entire project. So I mean that's what we are discussing so far. So we have not started with the hands-on.
Okay.
So yeah. Okay, all right. So coming to this monitoring layer, we have something which is known as the Prometheus alerts.yaml. Now, by name itself, it should be clear that we are trying to define some rule or some resource with some sort of alerting rules for our API as well as our infrastructure, right? Now, if you'll talk about the contents of this particular file, it is having something which we should be bothered about is this alert. Now, here we are saying that what should be the name of the alert. For example, even if you'll talk about this one as well, right? Now, this is high API latency. Now, this is something which we are considering as a scenario, that this could be a possible scenario right? Now we are saying that if there is something, now this is the expression. This expression could be different depending on what uh, method you want to use. So if in case you'll use certain libraries which are exposed, for example, there is this 95th percentile library. Now this is also one of the libraries that will give you some these kind of expressions. So based on these expressions, you can select that, okay, this is something that I want to use. I want to calculate the 95th percentile, which is, if I have to explain this to you in very simple terms, you can consider this as, it should just try to fire alerts before the user is able to notice any issues, which means within a fraction of seconds. For example, as soon as within a second it is able to understand that, okay, there is a high API latency, it should trigger the alert. So that's the basic understanding of what exactly we want to achieve here. Now, what's the severity? This is something which we want to uh, propose as the warning. Which component we want to apply this alert on? This is on the API layer. So as you can see here, transaction API rules. And then you can go here as the description, what exactly is there, right? And then we have some other alerts configured here. So let's say we have,
Where is the alert routed from? Here.
we'll come to that part. Yeah. So this is something, I mean, if you'll go here, it will be there for a specific resource. For example, if we are talking about uh, this transition API rules. Now, this is something which we are trying to apply on this particular component API, right? Now, going forward, when we'll try to apply this particular file, it will try to search for the components. So you will see if in case you'll go to the deployment YAML, you'll find some component known as API. It will try to apply this particular alert on that component here, this one, right? And then let's say, so basically most of these are applied on the API level, all these alerts. So that is how exactly it will try to fit in. Now it's up to you if in case you want to apply some alert on the DB, that is something that you can do. I'm sure it should be there. Yeah. So if you'll see here, it's the component is showing as the database, right? So there are some alerts on the API, then there are some alerts on the database, and then there are some alerts on the Kubernetes. For example, the pod is crash looping. What does that mean? It means uh, within an interval of 15 minutes, depending on, for every 5 minutes, like it will try to make some calculation here. And based on that, if in case it is observing that there are some frequent restarts for a particular pod, or a pod is, so that's what is known as the crash looping, which means it's trying to crash loop back off. There would be some error like this, and then again it will try to restart. Then again it will be saying crash loop back off, and again it will try to restart. So that is known as the crash looping. And again, if something like that is happening, it will be throwing it as an alert. Then we have pod not ready. Uh, if in case the same thing is happening for 10 minutes, it will try to use this expression to evaluate if in case uh, your pod is still misbehaving, and based on that it will be triggering the alert. And then the same thing will happen for when there is the low availability, which means you wanted some specific replicas to be up for a given fraction of time, but then there are very minimal pods, or there are no replicas created, then again you should be getting the alerts. So if you'll think from the SRE perspective, from the production grade environment deployment, you should be well aware of anything which is happening within your application. For example, if your application, now again, let me just try to open this diagram for you. So just try to look at this diagram and understand that, the issue could be arising at any of these layers. We have the monitoring layer, we have ingress layer, we have security layer, application layer, database layer, right? So your issue could be there at any of these layers. Now, it's highly unlikely that you being an SRE and you just got to know that, okay, oh, there has been some issue. Now, what will you do? Will you try to run the commands like this? Like, okay, kubectl get pods, hyphen and nginx, and then you will see, okay, the status is running, right? Now, this is very highly unlikely that you will be doing these kind of things in a stressful situation because there should be something which should tell you, because that would be too late by the time you are getting to this stage and things are failing, right? So that is why we need to apply the alerts at each and every specific resource level or each and every specific layer. For example, in the application, if you feel like there are multiple points of failures, so try to cover all those points of failures. That's the main theme around this thing. Like, we should try to apply the rules, the alerts at every specific point of failure. For example, in the database layer, if you feel like uh, there's only one point of failure, just try to apply it over there. And then if you feel like your application has certain layers, for example, there could be one server running, you can apply that alert over there that if this pod crashes or if this particular server goes down, then there should be an alert, right? So it depends. Like, it depends on you. It depends on how well you want to design your alert mechanism. Okay. And also, like, you can also define the severity here. Like, you want to throw it as just a warning, which means it's nothing critical. It's just a basic warning that uh, you just want to throw that alert as a warning, not as some critical issue that you should be looking at. So based on these severity levels only, you will be also taking the actions based on the runbooks. Now we'll come to the runbooks part later. We'll try to understand what exactly an SRE engineer should be doing in case of any severity alerts, right? But those are the things which we'll talk about later, definitely. Uh, so this is about the monitoring layer part, and then we have, I think we covered all the folder structures here. Yeah, this one is remaining. So you might be wondering about this piece here when I was talking about the security layer. So can anyone tell me where exactly you see the security layer here configured? Any wild guess?
Security layer between uh, the AKS and monitoring you're asking, or
Uh, so let's say when the traffic is reaching to the application, where do you see some sort of encryption, some sort of security layer applied? Okay, let me help you with that. If you'll see here, right, this secures. What does this mean? This means this is something which definitely would be part of our ingress, but then we are trying to apply the security layer, which means we are trying to configure something known as the cluster issuer using this library. Let's encrypt is the library which we are using here, and it's of a type cluster issuer. This means that it will try to automate this TLS certificate provisioning when the ingress has this particular resource deployed. So you can specify uh, again, like, any specific email that you want to share, or what is the server that you want to use, any specific secret that you are planning to use for this, and what is the class where you want to attach this particular cluster issuer to. So that is again going to be the nginx. Now this is the ingress class to use, right? And then this is something which is known as the challenge type. So there are different challenges in terms of the, let me explain to you it in form of whenever you're trying to evaluate the domain and you're trying to reach a particular URL, right? So internally, it tries to resolve a specific challenge to understand if it is reaching the secure server, if it is reaching the secure solver. So that is where it uses different types of challenges. It could be HTTPS, HTTP 001, or something like that. There could be some more challenges here, but that's the idea about that. Okay. Uh, then, yeah, I think we have covered the folder structure here. So let's dive back to where we left off today, previously. Okay, all right. So I think we left off at, we tried installing the Nginx ingress controller, this one, right? Now we'll try to install some of the other remaining things, and then based on that, so the idea is like we'll just install all the things, all the necessary stack that is needed, and then we'll try to connect them with each other. So that's the main goal, what or how we should be proceeding. We'll first try to install everything, right? We'll deploy all the things that are needed, and then we'll keep on configuring them in such a way that they start connecting to each other. For example, if you are seeing here the links, right? So let's say this is the routing, this is one of the routings, this is the routings. So all these are the connections. Now, as of now, what we are working on is we're trying to install these things. For example, we installed all these physical resources, right? We installed the cluster, we installed uh, the load balancers, we installed the ingress load balancer, we installed, let's say, I mean, now we'll be installing this Prometheus and Grafana stack, right? And then we'll try to verify some deployments, and then we'll start with configuring our different things. For example, the security issues. So let's proceed step by step. Okay, let me go to this folder. Now, what we'll try to do is we'll try to install our Prometheus and Grafana stack. So any application, I mean, this is something which we already covered, that this is something this which is needed as part of the monitoring layer in our architecture, right? And the outcome of this would be we should have some of the pods running in the monitoring namespace. We'll try to deploy Prometheus. We'll try to have Grafana for the visualization. And then we'll also have the alert manager, which will be using something like this, the alerts that we have configured here, right? Now, these would be the kind of things uh, that we can expect out of the output for this. So let's try to add. Now, this is something which we'll be doing using the Helm, right? So we'll have something like Helm repo. Now, either you should be aware about any specific repos that you want to use. For example, if you want to install the Prometheus using the Helm charts. So the best go-to way is you can always uh, Google it for that. Like, for example, if you're just saying that, right? Now, you can just go to this thing here, and then you will see this is basically the command that we need. Prometheus community Kubernetes help charts, right? So either you can directly copy it from there, or there could be other means as well where you can find out actually what is the repo that you want to follow, right? So let's go back to our this thing here. Now simply you just need to simply run this command. There's nothing more you want to do it. Okay. It says the repo already exists. Let's try to update our repo. All right. So it has added that specific Prometheus community to our chart repository. Now, previously, if you remember, we tried to install the ingress nginx chart to our repo, and that is how it is showing us this above message as well. So it will always keep on appending whatever charts you will be loading to your particular repository. Okay. Now, let's try to use the value file that we have here, this one, right? Now we want to use this particular file to install this Cube Prometheus stack, which is there with the custom values. Now, what are the custom values? We'll be providing using this particular file, this file. So by default, Helm is a very simple, easy to use tool. It has very specific commands. If in case you want to use, you want to understand what commands should you be using, you can always try to use helm hyphen hyphen help. It will give you the list of commands, right? So it should be like whatever name that you want to give. For example, here, let's use the same name here. Now, the same thing which we did for ingress as well. We are saying that I want to use the Cube Prometheus stack chart from the Prometheus community repo. Now, this is the repo that we know the name of. So we use this Prometheus community and then we'll give the same name because we are using the default name. It's nothing that we are using by our choice. It's just the default naming conventions that they provide. We are using the same things. That's it. And then we will specify any specific namespace that we want to use. So by default, we follow monitoring as the namespace. And then we'll specify that, okay, if the namespace is not existing, you should create one. And then we'll be appending this particular file path here. Now, since we are already inside this folder, I'll just remove this from here. Okay. Now, this might take some time. So let's say if you want to understand how exactly it's behaving in the background, there is one thing which you can do. You can always use something like get pods hyphen and monitoring. Okay, so you can see the containers are coming up, right? This is the exact uh, background stage which you can confirm with based on like what's the status with this one. Okay, all right. So if you'll see here, uh, it was able to install this Cube Prometheus stack, right? And we can confirm it using this as well. Let's run this command once again. Yeah. So all the internal containers required for this particular Cube Prometheus stack are up and running. Okay. Now this is one of the ways to confirm it. All right. So now what's next? The next is we'll just verify the couple of deployments that we made previously, just to understand if they are still up and running. And then we will continue with our next. Let me just clear this up. So let's verify if our ingress pods are still running. Okay, this is running. Uh, let's see if our service is still running. It's in the same namespace as the pods. Okay, we have the service also running in this particular namespace, nginx ingress. Okay, now there's one thing which we need to fetch. So we need to fetch some of the IPs which would be useful for us. I'll tell you where exactly those would be useful. So let me share one specific command formatting with you. I have some commands here handy with me. And I'll explain also this to you, how exactly, this command is formatted and how exactly we'll be using this. All right. So let's first try to understand this command. What exactly is this doing? So we'll start with this one first. I think this should be clear to you. This is the exact same command that we have used here. kubectl get service -n, which is the namespace, and then we are specifying the namespace. That's it, right? Till here it's clear. Now, here what we are doing is we are specifying the resource name. We are saying I am only bothered about this particular resource, which is the ingress nginx controller, and then I'm taking out the output into the JSON path, right? For example, if I'll just try to, run this command, let's say. So this is something which I'll just explain to you once, and then from later point of time, I think you should be having a good understanding of how exactly that command would work. Okay. So if you'll see here, what I mentioned is I said I want the output in the JSON format. If I'll not append with this thing, it will just be showing me the pod, like whatever pod is running, I mean, whatever service is running, right? But then I said that no, I want this output in the JSON format. That's where it is printing here the entire JSON of this particular running service, right? Now, let's say coming back to this command here, what we want to do is you might be wondering that, is there any way to filter out the values without us actually having to go inside this particular JSON file, and then we'll look for that, okay, what is the cluster IP? Okay, this is the cluster IP. I want this cluster IP, and then you'll manually copy it here. So ideally what you do is you use some kind of the filtering here. So this is nothing but the filtering starting from here until here. This is nothing but the filtering that we are applying. So I'm just trying to explain you once because this is something which we will use more frequently going forward. Okay. So let me make this easier for you. Till now, I think it should be clear what we are doing. We are using this particular command here, which is the default kubectl command to fetch any specific service within a namespace. And then you specify the name of the resource. You are saying I want the output in the JSON path format. And then now this is the filter what you're applying. What is this? What does this filter says? This filter says I want dot status. Let's go here. Let's try to search for the status. Here. This is the status, right? So now we just need to look into this particular group. Let's come back here. Status dot load balancer. Let's go even deeper. Load balancer. Okay. Now we just need to look into this particular thing. When we are saying we need to look into, which means that filter is looking into that. The scope is, getting narrowed. Now what it is saying dot ingress, and then it is specifying the zeroth element of the array, right? We all know what an array is. Array has the elements starting from the 0th position. So let's go back here. Ingress, and then how many elements are there in this array? Can anyone tell me in the ingress array? Anyone?
What is the question?
Yeah, I'm asking how many indexes are there in this particular array, ingress array, or how many elements are there?
Elements in the sense like IP address
Mhm.
is the only thing we have, right?
Cool. So we have two indexes, right? One is the 0th index, and then this is the first one. So two elements basically, right?
Okay.
So in an array, since it starts with 0, so this would be the 0th, this would be the element on the 0th index, and then this would be on the first index. So that is where we are
Okay.
specifying here that
Dave, even if it is related to the same uh, component, like so for like IP address, and
Mhm.
its IP mode is related to IP address only. So still we take every line as one
yes. So as soon as you will
element.
see this comma here, right? It means
Okay.
now
So
that is
between
something which you will
commas.
have to
Okay.
consider as the next element, which
Oh,
it would fall to the next index. And by default, if you'll see, this is the object in the curly braces, right? But as soon as you see something known as the square brackets, it means that that is an array. So this is an array, ingress array. Now, within this ingress array, we are saying which element you want to filter out. So we are saying I want the element on the 0th index because the counting starts from 0 here. So this is what
okay.
it will look for, IP. Now let's go back to the filter again. 0th element, now it came till here, this IP. It came till here. Now it is again asking for, it came till here basically. Now it's saying, what do you want from here, from this particular 0th element? So then you are saying that I want dot IP, right? So that is how exactly your IP will get printed over here. And then here we are just saying that, uh, this is just the printing message basically. This is uh, nothing logical. So as soon as you will enter it, it should print this particular value here, 4.149.209.69. Okay. So this is something which I wanted to explain because, ideally it might be a bit overwhelming sometimes when we'll use these commands back to back in a fashion. So now you should be having a very good understanding of how we are deriving any specific values because, typing these commands might take uh, some extra uh, time, which is not beneficial, right? So let's try to understand what all services we have running in our monitoring space, namespace. Okay. So we have this stack Grafana here, which we wanted, right? Now, this is something which would be very useful for us when we are dealing uh, with the UI part of it. You will also find some interest over there. But what if I want to fetch the IP of this one? What command should I be exposing to the system? I should be using
Yeah,
a similar command. Yeah, I
in
should.
place of the ingress
Mhm.
nginx controller, we can fetch for that particular Grafana,
Awesome.
right?
That's correct. Yeah, that's correct. Uh, so this is how exactly the command would look like, right? We are doing the same thing. We are just saying that, this time we just changed this internal command here. We just said that we want to use the service from the monitoring namespace, and the name of that
Namespace, yeah.
service is this one. And then this is how exactly we want to. So let's see. Yeah, now it is giving us the Grafana IP as well. This is the Nginx IP. Okay, perfect. Now there's one more thing which we need. We need it for this one as well. So we are just only fetching and exporting these values so that in our upcoming commands, it would be very handy for us. We can directly refer to this variable. We don't need to look for those values. So that's why it's something which we are doing as part of, best practices. Now again, there could be some more best practices, but then I would say maybe once you are much more proficient with those things, you can do it. For example, you can have an alias for all of these things, for all these commands itself, wherein I'll just use k monitoring, then it will just be displaying all these pods. But then we'll not understand what exactly is happening behind the scenes, right? So that's why I'm trying to print all the full, I mean, the full commands here. But by alias, it means you're just exporting it as something like export k equals to, and then you will just mention this, so that every time you just need to write k and then the the namespace which is there, k monitoring. So it will display all the pods over there. So this is just to give you an idea basically. So there could be n number of practices which you can call it as best practice or your own custom practice, but yeah, it's completely up to you. So let's try to get one more, this particular IP, sorry, this one, Prometheus one. Okay. Now this is something which would be useful for us for the later access part. So this is for Prometheus. Okay. Now coming back to here, this is for the reference which I'm using what all things we would be needing. Okay, so let's try to install the cert manager here. Let's see how it'll go. Now, so to basically install the cert manager, what we need to do is we first need to understand what exactly is this component responsible for. For example, are we planning to uh, install it to watch over the ingress resource, to watch over some particular resource or what? But here this time our concern is we want it to watch over this nginx resource. So that's why we will try to bind it with this particular nginx ingress load balancer. Now this is something which we are all doing as part of our capstone project. So you can again go back and try to refer to the requirements. Okay. Uh, so how would we apply that particular thing? First of all, we should be, now one thing we can do is we can try to go back to here, and just like we searched for this particular path, Helm path. So let's say if I want to have uh, the path to that particular YAML, the cert manager YAML, right? Now let me search for that path here. Okay, so either you can use this one directly from here, or else if you want to verify if in case it's from the official repository, let's try to open this one. Yeah, okay, it's the same one that we have. Okay, all right, so let's use this one. Okay, so it is trying to install, or you should say it's trying to apply the certificate managers here. It has applied all of that. right? Now let's see if in case it is, just to verify. Okay, so we have the pods up and running for our certificate manager as well, right? Uh, Now let's try to configure the issuer here, right? So basically the idea here is, our certificate manager needs to know where to get the certificates from. For example, for example, there is a cluster issuer, which is, you can consider it as like some certificate authority. It is like uh, a certificate provider configuration, right? So why we are using Let's Encrypt? Because it's an open source. It's a certificate authority, which is fully automated. And then it depends. Like, let's say if in case you want to use OpenSSL, there is one from their side as well. We can use that, but it's not automated. It's a manual one. So we are using this Let's Encrypt because it's open source and it's automated certificate authority. Uh, so, and I think, yeah, it's given by this. Let me just recall. Yeah, Acme. So this is their particular organization link here. Uh, so it will basically be doing the automatic validation that you own this particular domain. So that's the idea behind this, right? Uh, so what we'll be doing is we'll try to configure a cluster issuer that will tell the cert manager or the certificate manager to request the certificates from this particular server. The let's encrypt production servers. So basically we are just trying to configure this cluster issuer here. So how we'll be doing it is, let's try to go into this folder here. I'll just open it in the terminal. Okay. Uh, Now here we'll just try to apply this. Now you can give any name here if in case you want to give it up to complete. It's completely up to you. For example, let me uh, give my mail, for example.
I have one question. If security's perspective is the recommended to expose Grafana using an external load balancer, or should we route in through the application gateway or internal load balancer with the AD authentication?
Uh, Sorry, could you please repeat the question? I mean, I got the first part, but I just skipped the last part of it.
Should we, for a security perspective, it is recommended to expose a Grafana using an external load balancer, or should we route it through application gateway or internal load balancer to authentication, AD authentication, I mean.
Now it depends like what particular security provider you are using. For example, I mean, if in case your entire ecosystem is built around the Azure, right? So you could have something based on the AD authentication. That's fine. Like you can have some kind of integration of Grafana with the LDAP or SSO or whatever is there within your Azure ecosystem. But let's say, when I mean, it depends basically. So you can do it externally with the AD principles, LDAP, or whatever is there. I mean, the external load balancer, or you can also do it internally. But the preference is basically, since Grafana is an internal observability tool, right? So ideally, it is not suggested in some of the organizations, uh, and then they prefer the users to access this internal load balancer using some kind of a VPN network. I mean, this is something which we definitely might have observed in our organizations, right? This is a very default kind of enterprise pattern which is followed. And then let's say there are still some of the organizations which are more from the open source perspective, some open source organizations like the Linux Foundation and those kind of things. So they want their users to access Grafana from the internet. So you can now, but you still want to enforce the security at the load balancer layer from the external perspective. So what you will do is you can have something known as uh, IP whitelisting, or maybe you can have some mm, what do we say? Like there's this famous one, right? The Okta. Okta you can use the
Authentication of
AD, yeah. So these kind of things could be used. I mean, you can have some more security layers added so that you are very much assured that okay, it would be still not exploited by the users. Maybe you can have this Okta MFA multi-factor authentication kind of things. So I mean, in both the ways it could be done. It
yeah,
depends on what's
yeah,
the
got it. Yeah. Thank
underlying use case. All right. Yeah. So let's try to apply this cert manager that we have. All right. Now, if you want to verify if in case it is created, let's quickly verify get cluster issuer. By the way, this is the name of the resource, so it's not a default name. I know most of us are not familiar with this cluster issuer, but it's a well-known resource in the Kubernetes family. Let's encrypt. Okay, so the pod is up and running, as you can see here, right? Now, let's try to go to our DB layer, and then once this is ready, we'll try to, you know, configure everything with our Kubernetes artifacts. So we'll just quickly try to have this also ready, this part, which will take us to this one, right?
For certificate management, we use the kind as cluster issue. Is it something like that?
Yes, yeah, correct. So cluster issuer is something like let's say if in case you want to specifically tie some external policies to your particular resource. So you can use a cluster issuer and then you can specify that okay, this is the resource which I want to tie it on, and then certificate manager is just a use case of it. So that's why we applied it over there.
Okay.
All right. I mean, you can ask if in case your doubts are not getting cleared because that's the intention of behind these sessions, right? Otherwise, you can also I'll share the commands with you. You can try it on your own. But if in case you have any doubts running behind your uh, mind, you can definitely uh, clear them. So yeah, no worries with that. Let's try to deploy this PostgreSQL database, right? Now, I mean, most of us might be aware about this that I mean, apparently most of the Kubernetes workloads, are stateless, which means they are more like API servers, some web application frontends, which means they can be killed and they can be recreated without any sort of data loss. So, in that sense, we must consider that DB is something which is stateful. They must store the data, which is definitely persisting somewhere. It should not be like we are not creating something like RAM, right? Which is having just the temporary memory or something like that. We want to have a system which is stateful and which is able to persist the data, right? So that's the idea behind this. Let's go back to our database layer and then let's try to apply this thing here. All right. Let's see if in case the pods are in working condition. So one thing we can do is if you, let's say if in case you want to use something known as the labels, right? How would you use? You can use just -l, and then you can use app equals to Postgres SQL. So as we can see here, it's still container creating. Now the reason why we use this -l label is because it's not part of some specific namespace, right? So that's why, just to quickly find it, these are some kind of tricks basically which we can use. You can use some label selectors or something like that, because we know that there will only be one pod with this particular label selector, right? This is the label selector that we are talking about. Okay, now it's up and running. Let's see if in case our PVC is also up and running, because we have the PVC also as part of this particular deployment, right? So okay, so we can see the PVC is also there, and the good news is it's bounded. So this is something which we should be sometimes aware of. There are most of the times there are cases where you are not binding this particular PVC, and then uh, you would still you will be surprised that okay, why my data is not getting persisted. Uh, so the reason behind that would be it's not the binding is not done properly. Okay. There is another thing which we have deployed here, which is the service, this one. So we have PVC, we have checked PVC. Let's check for service as well, if in case it's up and running. Okay, so we have the service also, which is intact in place. Okay, now we'll just try to verify if in case our DB connection is intact, if in case the DB connection is working. Basically, let me clear this out. Okay, so the idea here is before deploying our application, we just want to verify that our database is functional, right? So this is also, you should think from the SRE perspective, that always try to catch the problems before they cascade into your infrastructure layers, right? So I think fail fast is the safest mechanism which an actual SRE engineer should or must follow, right? So that is also one of the reasons why we are trying to test this database connectivity here, and then we'll see if in case our Postgres is accepting the connections. Okay. Uh, let's try to use the command that I have here handy with me. Now this is a bit of a big command, but I'll explain to you how exactly it's working. So what we are doing here is we are trying to basically retrieve the PostgreSQL pod name here using this particular command. I think I just ran this particular command and we were able to fetch the pod. Now you are already aware about this filter, how to apply this filter, right? What it will give is it will be giving us the name of this particular Postgres pod, right? Now let's say once we have got the name of the pod, after that, what we are doing is we are trying to get into that particular pod. We are executing into that pod. So whenever you want to get into any specific pod in the execution mode, you'll use this command kubectl exec. Then you'll specify the pod ID, and then you'll specify the commands internally if you want to run. Now you can do this step by step, but this is all together we are doing it because we want some of the variables to be used in hand. That's why. So this is just kind of a you know a tied up command. You can call it as a tied up command. We have everything in place. But I think it should be easier to understand, right? Uh, Anyone, if you're not able to understand, I can explain to you what exactly we are doing again. We just are fetching the name of this pod here, and then you just specify and, which means this has to happen along with this command. We are just printing this PostgreSQL pod name here. Then we are trying to execute into the pod. First of all, what we are doing, we are trying uh, we are trying to basically do certain things here. Firstly, this is -u root, which means we are using the root user, and then in this particular database, transactions database, which we specified as part of our this configuration here, we'll just try to select the version, and then we'll also try to select how many users or what's the level of permission that it has. So let's run and see what info that we are getting. Okay. So what it is saying, it was able to give the version for which our DB is installed. And then it is saying that did not find any relations for this particular command, which means it was not able to find any specific user references, user relations, or those kind of things. Uh, so that is fine. I mean, that's not an issue or challenge for us at the moment. Uh, at least we have confirmed that our database is up and running, right? Now, the next step would be to get into our application part. So how would we start the application now? What do you think? What should be the ideal way to, run any application in Kubernetes, or even in general, if you want to, let's say, spin up the containers? How would you do that?
By either using means either a CLI or a pipeline.
Yeah, CLI. I mean, even with the pipeline, we'll be internally using the same mechanism.
Yeah.
So, yeah, what would you do with the CLI also? Okay.
Either
So to
using the
run,
kubectl and do or the Helm if you want to do in one shot of all the applications into the content into
Mhm.
Kubernetes.
Okay, got it. So yeah, basically what we'll be doing is, we'll try to run our application. If we are trying to run our application, let's say in Kubernetes, we can use Helm, we can use kubectl. That's completely fine. But Kubernetes cannot help us to build the containers. I mean, to build the packages. So to build the package, we need to package the code. We need
Use
to package
Docker.
the Docker image. Yeah, exactly. So we need to package the code. We need to package the dependencies into a Docker image. Then we need to push it to some registry, container registry. And then from there, Kubernetes will pull that image while creating the pods. So this is the flow basically, right? I think you all will agree with this particular flow. This is the flow basically which Kubernetes uses to spin up the containers, to spin up the pods basically. Pods can have multiple containers. So think it from that perspective. Okay. Uh, so what we'll do is we'll try to build and push this Docker image here. Now, I think this is something which we must be clear of. We are trying to do this particular action here. We are trying to pull the image from this. I mean, first we'll be building the image here, this image, and then we'll push it here. And then this Kubernetes cluster will try to pull this image, and then it will create the pods based on that, right? So why we are using this ACR is because it's a private registry. It's not like Docker Hub, and then it's integrated with the Azure security by default because we are using the Azure ecosystem, right? And yeah, so that's what we'll be doing. Like we'll try to build and push, and then it will populate the ACR with our application image, and then that image would be pulled by this particular Kubernetes cluster. Okay. So let's try to go to deployments. Okay, we are already in deployments. Okay. So I think by default, we all should be knowing about what's the command. Okay, we have this application code here, and this is what we will try to use to build our image, right? Let me use, now since our project has a specific name, it's for built for some sort of transactions and, fintech related use case, finance use case. So let's try to use the image name as this. And then we are saying we want to build the image in the this particular current folder. So let's see how it goes. Okay. Now what it is saying is it is saying it's not able to find the Docker image here. Sudo Docker image. Okay. What it is saying, the KC builder is deprecated, unable to prepare context. Hmm. Just give me a minute. A moment. I'll try to. Okay. All right. Cool. We are in the wrong directory, I think. There's no. Okay. Here we have the Docker file. Okay. All right. Yeah. So you can see the Docker image has created here, right? It got created here. Now let's say if in case we want to tag this particular Docker image, so how would you do that? What you'll do is you'll try to, quickly use some command like, let's say, and then you'll use this name of this image. And then you'll use the version for this one. I mean, yeah, this is the version latest. And then you can use probably the name of the ACR where you want to. Let me use the default one which I have. Okay, let's check it again. Yeah. So now you will see the name itself is reflecting along with the tag, right? So that's how exactly we tag the image. Uh, let's try to log in into our ACR. Okay, it says login succeeded. Now we'll be needing the credentials for this particular ACR in order for us to do the Docker login and push that particular image. So it's a pretty straightforward process. You just use this command, run AC. Okay, I think let me run this command. Okay, now let's try to see if it's showcasing the credentials. Yeah, it is showcasing the credentials here. Uh, so we have the command which goes by this name, right? Now we need to give this password here. You can give any of these passwords. That's completely fine. Okay, so you can see here the login is succeeded, right? Now, which means we are able to log in with these admin credentials to this particular ACR. Now, what we'll do is we'll try to push our Docker image to this particular ACR. So this is the command that we use, sudo docker push, and then the name of the image. That's it. Awesome. So as you can see, here it says the image is pushed, but let's say if in case you want to verify it, I don't have that command, but it should be like, okay, so you can use the help command here and we can understand that, okay, list is something which could be used from here, right? So let's try to list down the image. I think it should be repository. Okay, so it wants the name of the the ACR, basically what we are having. The name of the ACR is this one. Okay, I think it needs to be passed as the flag hyphen hyphen name and then the ACR name. Okay, so yeah, I think it is reflecting the list here, right? Which means with whatever name that we pushed this image with, let me show you what was the name that we used. Yeah, here you can see this is the name that we used, Go demo, and then version v1, right? So you can see with the same name, our image is pushed to this Azure ACR, right? Now, so what all things we have done so far? Let's try to understand. We have our database ready with us. We have our application image ready, which we have pushed to the Azure Container Registry, right? We have our ingress layer ready with us. We have our monitoring layer ready with us with all these 17 rules configured. Uh, Now, the part which is pending is to have the connections, to have the routings basically. For example, we have not configured our ingress so far with our Nginx IP, which, I think exported somewhere here. Yeah, this was our Nginx IP, right? So now we'll try to have those connections established. The configurations, the deployments are in place, but then we need to think from the configuration perspective that, okay, how to link those configurations, right? So let's try to, let's do one thing. Okay, so what's the ingress IP we have here? One second. This one, right? Let's go to our ingress.yaml here. Okay. And then if you'll see here, we have this one, which is basically the old one. So we need to update this here with the new one. Okay, it's just at two places. So that should be fine. Now the intention of doing this, I think you should be able to understand. What we are doing is we are trying to update this ingress YAML file with our Nginx load balancer IP so that the external traffic can reach the application based on this particular correct IP and port that we are doing. So this basically is more like, the ingress resource that connects our Nginx ingress controller to our Go application. So this routing which we are taking a look at here, right? This is something which will be happening once we'll try to apply this layer. Okay, so this is the idea behind this particular configuration update. Okay, now we fetched how we did this. We just fetched the Nginx IP for our Nginx from our Nginx ingress deployment. This is the external IP. If you'll see here, always we try to use the external IP. I'm sure this would be visible to you, and that is what we have updated here. Now, host is something which we are trying to use. This is again an open source domain that we are using .nip.io. Okay, so let's see how it goes. Now what we need to do is we let's reconfirm from here. We will be applying this thing, so this change is in place. Okay, all right. So this is done. This is, I mean, this is ready for the next part. Now, once we'll be deploying our Go application. So at that time, this particular file would be needed. So for now, I think, yeah, let's proceed towards the application deployment. Now, in order for us to proceed towards the application deployment, one thing which we have done is we have pushed our images to the ACR, right? Now, what's remaining is we need to enable this application in order for it to pull the secrets from here. So you might be wondering that if we are able to push it to the ACR, then we should be able to pull it as well, right? Now, even for pushing it, you might have seen that we configured some DB credentials here, right? It was uh, some good amount of efforts that we applied here to set up the credentials, right? So the same credentials we'll be using, and then we'll try to create an ACR image pull secret. So the idea behind this is Kubernetes needs the credentials even to pull images from the private repositories. So there are two ways through which you can do that. One is you can use some AKS to ACR integration using the Azure portal, portal.azure.com. You can go there. You can use some managed identity, which might be requiring to have to you which might be requiring you to have the owner role. Or the other easy approach is you can use some sort of username password, which would work even if you are having some contributor role, right? So let's try to see how exactly it goes. We'll look into that. So firstly, I think we already have that command in place which we used. So this is to show the credentials that we generated for this one, the same one which we already used, right? Now here basically, we'll have to create the secret, this one, using the data that we have got here. For example, the credentials that we have received here. So we'll have to create the secret with the username and the password that we have received here. So that could be done in multiple ways. Either we can, use the Kubernetes kubectl way, directive way, wherein we'll have some boilerplate code and then we can update it there, and then that secret will just apply it. Or the other way is we can directly use it, some command thing like kubectl create secret. Okay. I think this would be something like this Docker server. Then we need to give username. So the username would be this one. Okay, sorry, I think the username would be this one. We updated it wrongly. Yeah, okay. Now let's verify if we have passed all the things correctly. We have passed kubectl create secret Docker registry. We have provided the name of the Docker registry. Docker server is this one. The default value that we have, username is this, and then the password is this. Let's see. Okay, all right. Let's see if the secret is persisted in Kubernetes. Perfect. So we have the ACR secret in place, right? Now let's proceed with the deployment of our Go application. So we have all these, what do we call these? Uh, Kubernetes manifests are there in place. We have the deployment YAML, we have the horizontal pods autoscaler, we have ingress, we have secrets, and we have service monitor, right? So these are basically multiple Kubernetes resources. Each of them is having a specific purpose. This is something which we have realized so far. Secret is something that stores the database connection strings, right? It is having the database URL and then the secret that we configured as part of the DB. Then we have the deployment here, which is having the pod configuration, the replicas, some kind of rolling updates here, and also the health check, live liveness probe, readiness probe, right? And then we have the service also in this one, I think. Yeah, this one. We have the service here, right? So it's basically to apply the load balancing part. Some kind of stable IP, some DNS would be applied on top of the pods, and then we have the ingress here, which will be routing the external traffic from the Nginx load balancer to our this service that is defined here, this one. Okay, and then we have this HPA, horizontal pod order scaling, uh, and then we have the service monitor. So this is something which will be telling the Prometheus where to scrape the these metrics from. Okay, so we'll try to deploy all these Kubernetes manifests for our transaction API application. So it's it could be done through two ways. One is like I can directly use kubectl apply -f, and then I will use this folder and slash. So it will apply all the YAML files which are there. Or other thing which you can do is you can always be little patient and you can try to apply them one by one. For example,
So I have a small question.
mhm.
Instead of creating the ACR image, pull the secrets manually using kubectl, right? Should we use seal secrets? The credential can be safely stored in Git.
uh, how would you store the credentials in Git?
We can seal the secrets to.
I mean, ideally, it is not the recommended way because you are always uh, I'll use the word punished, or maybe you are restricted from using the secrets even though you're trying to use the sealed secrets. Uh, it's altogether a different thing. I mean, if you're trying to upload it to the Git, I would not recommend it. But then, yeah, if you're planning for the sealed secrets, those kind of stuff, then that is also one of the ways which you can do it. But normally, I think in Kubernetes for pods, it tries to pull the images from the ACR for which it needs the credentials, and the credentials within the Kubernetes ecosystem has to be stored as part of the Kubernetes secret. Now, let's say if you still want to you suggested this. I mean, by default, you will not be storing the plain secrets anywhere, right? Even in the Git, it's kind of prohibited basically. But
Mhm.
let's say you're saying sealed secrets kind of thing. So that would require you to have another resource, for example, which should be able to, first of all, you'll have something like secrets controller, sealed secrets controller, let's say, right? Now, what you'll be doing is you'll be using that sealed secret, and using this controller, sealed secret controller, you will have to convert it again back to this real Kubernetes secret, right? So I believe it would be again kind of a rework here. So, but that definitely can be done, and many organizations use that. Uh, but yeah, I mean, in our case, the easier approach would be, since we at the end we have to use the native Kubernetes secret, so we can directly, you know, use it directly here by creating it. But yeah, if in case, your organization has been using some of the other mechanisms to generate the secrets, for example, there are some
So we are
organizations.
using Argo CD perspective, so we are planning to seal the secrets to this way.
Exactly. Exactly. Correct. Yeah. So from that perspective, I think you can use some sort of sealed secret controllers as one of the resources, and then you will be able to pull your sealed secrets from wherever you have stored them. Let's say you have some uh, storage registry for them, and then from there you will have to
That also.
again fetch them and recreate the Kubernetes native secrets. So that's how the process is, and I mean that could be done. So that's something which could also be done as part of that.
Thank you. Thank you for
All right.
clarification.
Yeah. Okay. So let's try to apply this here. We'll first start with the secret. Okay. Secret is created. Then let's start with let's continue with the deployment. Okay. We have the pods and services file created. I mean, we'll verify it again, but for now, just let's create it. Okay. What else is remaining? This one. Okay. Now Okay, so if we want to fetch the service, yeah, it is up. Now let's try to check for ingress. Okay, this is also up and running. What else do we need to check? We need to check for if our HPA is intact. Okay, yeah, all right. So this is also in place. You can see the targets are reflecting here. Okay, somehow it's showing unknown for CPU as uh, the request, but yeah, it is in place. All right, now let's go back to our diagram here. Okay, so what we have this part also completed, right? Now let's move towards the this flow. Let's say if you are an end user, so we must verify that our certificate manager and our certificate is working or not, right? So if we'll think from that perspective, we'll try covering all the aspects from the end user perspective. That's how you should always be thinking from even from the system design perspective. Always try to navigate from the end user perspective. Okay. So I mean this is only applicable when you're trying to think from the traffic. Uh, all right. So let's verify this. What we'll do is we'll try to, first let me clear this out. So we'll just basically be verifying if our certificate manager has provisioned the TLS certificate from that open source library which we were talking about, right? Let's try to first fetch the certificates that we have. Okay, the certificate has created. Let's try to see if we have the certificate request as well. Okay, so if you want to describe it, maybe you can just run this command. Yeah, so this is what we were discussing about, right? It starts with this thing waiting for approval. And so since basically that's an open source organization, but it works in an automated fashion, we had our cluster issuer, which you would remember we deployed previously. Uh, so sorry. So it tried sending one request to the cert manager, which is our certificate authority, and then certificate authority manager, which the cert manager, it said that, okay, let me do a few work for you, some work for you, few things I'll do. I'll try to request it from your certificate authority, which is this open source organization, which provides the root certificate. And then it will be creating the certificate request, which is commonly known as the CSR. So your CSR has to be approved or signed by the root certificate authority, which is ACME in this particular case, right? So this was the process which it followed. Initially, it was waiting for approval for maybe a couple of minutes, and then you can see certificate request has been approved by cert manager, and then it created this order resource. So the order resource means it has to only after the approval is received, it will process the the creation of this secret resource, TLS secret resource. So this is something which internally the applications would be using. And now it was waiting on the certificate issuance from this order, this particular application, to get attached to our certificate. I mean, to get attached to our this Nginx load balancer. So that is how exactly, this entire process goes through. So I just wanted to give you a brief walkthrough of how exactly the certificate is fetched from the issuer and how it is, uh, attached to the the CA which you have, the cert managers. Okay, let's clear this up. And now again, like there's one more thing which you can do if you want to fetch the specific details of the certificate. You can okay, so these are the details that you will get for this particular certificate. What's the API version? What's the kind? This is the certificate that has been provided to you, TLS certificate. Okay. Uh, where it is attached, you can identify from here. Ingress, Go app ingress, the one which we have. And then all of these things, unique IDs are getting generated. And then here are the specifications. You might see the IP which we applied for our ingress, the one which we fetched here, right? It's the same one. If you'll see this one, right? Then we have the cluster issuer who was acting as the issuer reference here. It uses digital signature, key encipherment, and all the things that are there. Certificate is up to date and has not expired. Uh, and then these are some details of the certificate expiry, right? So now, I mean, there are times, when you can see some kind of errors here. So initially when I tried, for the first one or two times, I got some errors like failed to create order, like here in this process. Let me show you this one. So here, this thing was not fulfilled. I mean, it waited for, see, you can see the age here, right? Uh, this was not fulfilled. So this is a heads up which I'm giving to you, that when you might be trying, there is a possibility that, this ingress might throw you some, I mean, not ingress, but this particular thing might throw you some rate limit error. The reason behind this is this nip.io, which we are using. So it is a very, very popular service. It's an open source, and this could be expected because if in case there are too many certificates which are already issued within a very specific interval of time, let's say there are some n number of users who are trying to get their certificates as part of the similar setup, right? They are using some sort of applications and they want to use some open source certificate providers, and their orders are in the queue. So there is a possibility that you might get some errors like rate limit errors. Basically, it'll say failed to create order, too many certificates already issued for nip.io or something like that. I mean, it depends. I am not exactly able to recall that error, but it's the rate limiting error basically that you might get. So what you have to do is just wait for the rate limit to reset. It usually resets in some time, and then you can again retry and then it will work fine. Okay. This time, fortunately, it worked fine in just one go. We didn't have to wait much, so that's a good thing. Let's continue from here. Now I think all of our deployment is working fine end to end. Okay. Uh, so now we can think from testing it from multiple fronts. We can test it at multiple layers. We can test it at the internal cluster IP level, which would give us some kind of confidence around, the the pod to service connection. If you'll see here, let's say there are some pods within the application. So we are talking about this layer here. So the pod is also there in this layer. the service is also in this layer, and this everything is there within the same cluster. This is something which you can test, which means the traffic is somewhere within this layer, right? Now, let's say there is some traffic which is coming from outside, which means you being an end user is trying to call this service. Your traffic, I mean, your request would be coming to this ingress. It would be going to the this ingress. It will get resolved here, and then it will be coming to the service, and then it will be going to the pod. So these are the two flows with which we can validate if the entire request path, even including this TLS termination and all that stuff, is working fine or not. So let's try to run a few commands to verify if everything is working all right. Okay. I think I should have some of the commands handy with me, which I'll again explain to you. So firstly, I think we already have the Nginx IP configured here because that is something which we usually need. So let's try to run this test health endpoint, which we have configured within our deployments, right? So what we are doing here is we are just saying that just run this particular command interactively, and we are not in the debug mode. So that's why I'm saying that I don't want to be in the debug mode. Remove any debug logs from here. Then image is the curl image which I'm using. Curl is something that you can use to hit to any particular API, right? And then we are saying that no, I don't want to restart it. And then this is the multi-line thing. And then we are saying that, okay, hit this particular endpoint. This is our application endpoint by default. I mean, the one which we have configured. Go app service dot default dot svc dot cluster dot local, and then this is the /health endpoint which we configured here. You might be seeing in our this file here, this one /health, right? So what will happen is, let's try to run this thing, and it should give us
Dave, can
okay.
you explain why we are giving the
Sorry, hello.
over here, like why we are passing that?
Yeah, I just explained, right? Like which specific thing you want to?
Hyphen image equal to curl images, right? Yeah.
Hyphen image equals to curl images. All right. Okay. So what we are doing is we are trying to, you know, run this entire API check as part of our kubectl thing, which means we are trying to basically create a temporary pod to run this particular command. Now here this -i means -it means it will try to allocate an interactive terminal for your particular pod within which your this request will run. So this is a very, prominent method to basically execute your some of the internal health checks, which are internal to your Kubernetes ecosystem. So I hope this part is clear. Run -it, right?
Yeah. Right.
Yeah. Now coming to this one, -rm debug. Now we are saying that you delete this particular resource, whatever you are creating, because this is something which I am creating for, uh, let's say, debug or testing purpose. So I don't want any kind of leftovers. So you delete this thing as soon as this thing is tested, just after the exit, which means as soon as you will exit from this particular temporary pod, it will delete this particular thing, right? Now let's come to this part. Image equals to curl images /curl. Now this is something which we are specifying that please use this image for your temporary pod creation. So by default, whenever we use this
Okay.
Kubernetes,
But you are creating an image out there. So through that, like how we run our CI/CD pipeline, we create an agent and run.
Exactly. Yeah.
Similarly for this. Okay. Got
Yeah.
it.
So this is just one of the ways to test out if in case you want to create some temporary pods. Uh, you are just specifying that I want to use some this kind of image. I mean, curl is a very lightweight image container which uses this curl CLI, and then you can just pass in whatever API that you have. So, I mean, till here you are just creating the temporary container. That's it, nothing else. But since you
So
specified that,
this gets created in the default only, right? Namespace
yes, that's correct,
or
default,
like
the default one, yeah. And then since you specified this hyphen IT, which means you have uh, specified that whatever command that I'm going to share you next, you you run that command within this container. So if you will not apply
okay.
this, it will not be running this command, right? So that's how exactly it created the temporary pod and then it executed this particular
Okay.
URL.
So
And
when you're when you're mentioning restart never, right? When we run a command, when because this is not a deployment or anything, right? So we are just using a command called syntax run, right?
Mhm.
So it doesn't fall into means even Kubernetes doesn't take care of that to run means to restart or anything of this particular pod. Is there any specific reason we are giving that parameter also hyphen restart is equal to never?
Yeah,
Because if
so the
this once exits and dies, right? So it never Kubernetes never takes care of
good
the
question. All
pods
right.
which are created with the run command, right? So
Mhm.
that's why.
Good question. All right. Let me try to explain that. So I think default behavior of kubectl run is if you are not specifying hyphen restart, right? Kubectl, I mean, this Kubernetes might create some very high level controller instead of the simple one-time pod. I mean, it could create, ideally, it should create a deployment which then tries to keep the pod running. But then there is a possibility that, it will try to keep that temporary pod running till the time it is exit. I mean, it is exited. But let's think of a situation where, here this was not healthy and it was somehow it was crashing internally, which means it might not be getting exited. So in that case, you are you have not specified to Kubernetes that you should just have simple one-time pod, but you just asked it that you create some temporary pod, but you never specified that you should not restart it or you should restart it. So that's why like we specify that okay, restart never. You are
Got
forcing
it.
the
Yeah.
you are forcing the Kubernetes basically to create the
You are
command,
instructing very clearly, like, yeah, it should not
run the command only for
restart.
once,
Yeah.
and then do not
Once
restart
again.
if even if you are trying to exit. So that's how this life cycle works.
Yeah.
I guess this is clear, right?
Yeah, it's clear.
All right. Awesome. So as we can see here, it says the status as healthy, right? And then uh, you can see this message as well, pod debug deleted from the default namespace. Okay. Uh, so this was basically internal health checkup, which means we know that, okay, internally things are working fine. Right now, how to test it out via the ingress? I mean, we want to test this health endpoint from the ingress. So how to do that? Uh, Maybe we can try to hit directly our Nginx, which is there. So maybe let's give it a try if in case that works.
Yeah, it
Now,
should
this is
work.
something which, yeah, correct.
Because this is a publicly means the IP address which is on
Mhm.
public, right? So we should be able to directly ping on that.
Exactly. Yeah. Okay. yeah, so it is working even from via the ingress. Now this is something which we tested internally, and this is something which we tested through the ingress. So it's like it was uh, ought to happen. There is nothing like, it was working there and we applied some restrictions here, so it should not work here. But yeah, the idea is we tested it internally as well as we tested it through the ingress as well, right? So from both the patterns, we observed that, yeah, it's working. But
Yeah,
now
the
let's
traffic
say
is flowing from ingress. Yeah,
exactly,
it proves
exactly,
like, yeah.
correct. You're right. Uh, Now, I think let's say, I mean, we have tested the traffic, but let's say if in case we want to send some test transaction, which means we want to send some post request to create some new transaction in the database with the APIs that we have configured here, right, as part of our application, if you'll see. So there are some there are some APIs that we have created here, and there's this create transaction method, which will be basically creating a new transaction in the DB via the API. So if we'll think from that kind of testing perspective, then what we'll have to do is we'll have to write uh, the path from ingress to service to pod, and then if you want to insert some DB. So that is how exactly we'll be forming this particular query, right? So let's try to form one query around this. I think we already have this thing. So we'll just use this one. Okay, I think this should not be needed because we'll have to use the post API here. By the way, you might be aware about why we are using these flags, right? -K is typically used for skipping the SSL certificate verification. Since we are using the HTTPS here, it might, force to check if in case this is HTTPS is having the secure certificate attached, the SSL certificate attached. So if you'll say -K, it will try to skip that SSL certificate verification. And yeah, I mean, that's the idea behind that. So let's try to have the headers. I think I should have it somewhere, default values. Let me use those. Okay. And then this is for the headers. And then I think we need to pass the payload. So the flag that we use for the curl is -D for payload. Okay. And then we need to use the single quotes here basically to, if in case you want to preserve the string formatting within those payload objects that you have. For example, I have the sample one here. Let me use this one. Okay, so what values do we have here? Let me try to explain this to you. It's just there is this value field and then there is this timestamp, right? So as per how we have configured our query, if you'll see here, what we are trying to do is we are trying to insert the value. This could be some amount, and then there is this timestamp. So let's try to see how it behaves. Okay, so as you can see, the DB is also working intact, and we can understand from here the status was completed, and then it is showing the timestamps as created at right? We just gave the timestamp for which we were trying to insert it, and but the other two things are system generated. So that's how we are able to get the working response. Now let's say if in case you want to create some other transaction with some other value, let's try that one out as well. Let's change something here. Let's make it 275. And then let's say this transaction, maybe this occurred somewhere at around, maybe you can call it as 14. Okay. So this is the post endpoint uh, that we were supposed to have, and this is working fine. Okay. Now let's say if you want to work for some get transactions, if you want to work some for, I mean, you want to test some list or get APIs. So mm, maybe you can use the same slash transactions, and I think you need not to specify the get. Okay, yeah, I think yeah, we need to hyphen s should be fine here in this case. Okay, all right. So if you can see, we are able to receive both the transactions that we performed, the one with the value 150 here and the other one with the value 275 here, which means, I mean, as of now, like we are not bothered about what code that we are writing here. It's definitely based on the assignment that we had, but the point here to note is our intention was to test whether all the APIs are working fine or not, right? Now we have the APIs here listed. If you'll take a look, uh, we have something for creating the transaction, then for listing the transaction, then we have for get specific transaction, then for specific health check, and then for fetching the metrics, right? So all these kind of transitions are there. But yeah, for testing the database connectivity, we were able to test out these two transactions, which makes it understandable that this particular application is up and running smoothly. Now there are some other testings which we need to perform as part of our capstone project instructions provided. So it's more from the external access validation perspective. So the idea behind that is, after deploying any application, you need to validate if it is working correctly. This is not just does it start, but you need to verify that if the traffic can reach the load balancer ingress service pod, which we did here, if your API endpoints are returning the correct response, which we checked here, and then if we can create the data that is persisting to the database, which we also tested here using the list API, right? So that is how exactly you perform these kind of testings. Now you can also do the testing through the UI, because this was from the CLI perspective. But let's say if someone of you might be interested that I want to test it using the browser, so that is also possible. I think if you have your own systems, you can give it a try. You can try to use the base URL that we have here, and then you can specify this nginx IP, and then you should be able to test this out. This should work over there as well. Okay. If you want, I can give it a try here. Let's see if it works. So let's start with this one. Okay, so if you can see here, the status is healthy, right? Let's try to test out. Uh,
Are you trying it on a browser?
okay, I think you might not be able to see that particular part of screen because I have not shared that one. Let me try to share it. One second.
You can just give us that URL. We can just
Sure.
Can you please share all commands, if you don't mind?
Yeah, I will be sharing all these commands as part of, the runbook that I'll be sharing with you. Let me try to share it in the chat. Just see if you're able to access this. Okay.
Yeah, status is healthy.
Which means you are able to connect, right?
Yes.
So, okay, all right. Now let's see if in case we could make the other transactions work. I'll try to share this one, the list one, right? Now just confirm if you're able to see the transactions that I just performed.
Yeah.
It's working, right?
Yeah.
Perfect. Let
275
me.
and 150.
So for your preference, I mean, for your reference, I'm sharing it here as well. So for those of you who are not able to test it out, you can just take a look. This is how exactly it looks like when we are looking at here, and this is the health API one. Okay. Let's go back to our VS Code. All right. So I think let's try to conclude this session here. And the next remaining part would be, how exactly we'll delve into the the monitoring section, how exactly it behaves from here. So let me try to give you a recap of what we have covered so far. We were able to bring up all the individual components in terms of the database, our ACR container registry here. Then we were able to bring up our entire application, which was built using the Golang APIs, and it had the pods, services, ingress components, all of that stuff. And then we were also able to integrate this let's encrypt TLS security certificate to our ingress controller. And we were also able to bring up the Grafana and Prometheus services, which are currently working with the 17 alert rules. And then we tried running some queries from our application internally, which confirmed that our transactions are working fine. Our all the APIs that we have, you know, uh, created as part of our application are working fine. Our DB is trying to persist those transactions. Uh, we'll also do a couple of more testings tomorrow. We'll try to, delete the pods, and then we'll see if our DB is still able to persist those transactions. Those kind of checks we'll do. And then we'll also try to focus more on this particular area, which is the monitoring part of it, to understand how exactly Prometheus is able to scrape the metrics from all the pods, all the services, and how we are able to visualize it using the Grafana. Okay. So any doubts, any questions so far regarding the things that we have covered?
Nothing. Just we need to
This
Mhm.
session is more informative.
do some hand. Yeah. Like
Yeah, I have one question, one more thing. In this setup, where would you
Mhm.
Argo CD fit to the deployment flow? Can you explain? I mean, tomorrow class or day after tomorrow, whatever in your.
Yeah, absolutely. Sure. Uh, we can use either Flux or you can use Argo CD. Uh, so all those kind of things can definitely be, included as part of our this architecture here. And let's try to understand all those kind of things here. What future possibilities could be appended here to this existing thing. But that is, I think, more from the DevOps perspective. But yeah, it's really interesting, and we'll try to understand where we can fit into this architecture.
Yeah, sounds good. Thank you.
Yeah. Okay. All right. Thank you all. Thanks for joining. See you all tomorrow.
Thank you. Thank you.
Yeah,
Thank you.
thank you.